All right, we are back. Our next lecture is on types of chemical reactions. With this lecture, I'm going to break it down into two separate presentations. The first one is going to be on synthesis and decomposition reactions. These are the first two types of reactions that are in this PowerPoint that you can get on your D2L page. And then the second one is going to be on, obviously, single displacement, double displacement, and we'll throw combustion in there as well, both complete and incomplete, very quickly. So today, synthesis and decomposition reactions. So we'll bring this up. Again, these are on your D2L site. These are your notes that you have from class, and I'll use the board here for, well, whatever I have to write down or anything like that. So quickly, what is a synthesis reaction? Synthesis simply means to make, right? We're taking small things and building something really big from it. Smaller components or parts, putting them together, make a larger molecule. That's all it is, to build, to make, right? Plants run photosynthesis. They use the energy from light, which is the photo part of the word, to build or to make larger molecules, in that case, glucose. So synthesis means to make or build. We take two or more simple substances and combine them to make a more complex substance. For that reason, they're also known as combination reactions. The general equation for this is, and I can see it here, A plus B yields AB. Now on the periodic table, we don't have A and B and AB, but generally this means we're taking the first substance, combining it with a second one to make just one substance here, a larger substance that contains both of these. Each of these slides is going to have a hint. Hey, how can I tell that that's a synthesis? The hint for synthesis is, there's my yield arrow, right? This is showing what I'm making as a product. If there's only one product, it's a synthesis for what we're doing now in grade 11 anyway. So this is a synthesis reaction. I've only got one product. It's whatever this compound AB is. So that's it. Some examples I can see here. I've got carbon dioxide and water coming together to form carbonic acid. I've got iron and oxygen coming to form iron 3 oxide or rust. And I've got lithium oxide and water forming a base, lithium hydroxide. So we'll go over several of these again. I'll give you some examples. Now, I added this slide because there are three types of synthesis reactions we're going to see over and over again. So on the initial PowerPoint, you may not have this slide in your note. You can go back and get it because I reloaded the PowerPoint and this is now part of your notes. So normally I would do this in class, this slide right here in class on the board and go over it with you. We're in different circumstances now. We're all teaching and learning from home. So again, see my presentation on stupid viruses. But I decided to add it and so that you could have it in print form and when you print it off or write it into your notes from home, whatever you're doing. So this I'm going to do right here. I'm going to do it nice and slow with you, and then we'll get into the decomposition stuff. So the three types of synthesis reactions, we have simple synthesis reactions. Basically, when you take two elements and throw them together. Then there's the formation of bases by using a metal oxide and water. And then the formation of an acid from a non-metal oxide and water. So I'm going to draw several examples here for you, and then we'll go from here. All right, so if you have your note, this is kind of what you'll see. You'll see this stuff. So all of these will come up. I'm going to do those with you on the whiteboard because that's what I normally would have done in class to show you how to do this. So I'm going to move the iPad out of the way. That will stay there for now. And let's go through these. So the first one is we call it a simple synthesis, or I do anyway. I don't know if that's the official name for it. But what's simple about it is it's just two elements coming together to form a compound. So our first example on that sheet, or on this slide that you now have, is aluminum plus oxygen yielding aluminum oxide. Now we know aluminum, any metal by itself, and aluminum's a metal, is by itself. It's actually one of the rules of Fight Club. Any metal by itself is by itself. Oxygen, not so much. If you remember, oxygen is part of that hockey stick and puck thing we were talking about, those diatomic gases. So oxygen, when it's by itself, will find another buddy and pair up with it and form oxygen gas. So metal by itself, leave it there. Don't put a 2 here, don't put a 3. Aluminum's fine. It's happy. It's in isolation and doing all right. Oxygen has a buddy. All right? So I know that A, L, and O come together. Now, our formulas, we can make the formula. We know this is a 2, this is a 3. Using those numbers are not the same, so using the crisscross method, that 3 would come, oh sorry, I just reversed that. I've got to fix that. Stupid sir. This is a 3, that's a 2. So the 2 would come down here, the 3 would come down here. And so aluminum oxide, I was giving you the formula before we even worked it out. Aluminum oxide is Al2O3. So this is our skeleton equation. It isn't balanced yet, right? So we start balancing it. Al, I've got 1. Here I've got 2. So at first I think, oh, I'm just going to throw 2 here, and you'd be right. But then there's a problem, right? You can see it's coming down the tracks here. I've got 2 O's going in, 3 coming out. And we said this would happen a lot in chemistry, where we have 2 of something on one side and 3 of something, the same thing on the other side of the yield arrow. When that happens, we have to make them both into 6. So to make this into 6, I multiply it by 2, and I have to use a coefficient. We talked about this in a previous lecture. Have to use a coefficient in front that impacts both elements. To make this O into 6, I take that 2 and multiply it by 3. Now, from a previous lecture, we said every time we add a coefficient, we have to go back to the start and go through the whole thing and review it. So I've got 2 ALs here going in, but now I no longer have just 2 ALs. I've got 2 times 2, which is 4 ALs. So that one's got to go, and there you go. Again, a simple synthesis reaction. Aluminum, one element, oxygen, another element. You're bringing them together. You still make up the formulas using the crisscross method in this case because it's ionic, but you still make them up the same way we would in class. I don't make this up and just go, oh, it must be Al and then O2. Oh, I made AlO2 because we know they don't go together that way. So use your crisscrossing and make up the formulas correctly. Our second example of a simple synthesis is Na plus Cl, and that's going to make NaCl. Now let's check our formulas. Metal by itself, that's fine. Cl though, it's like oxygen. It's going to be a diatomic gas, and NaCl. Na is a 1, Cl is a 1, that's fine. So that formula is okay. So now to balance it, I simply am just going to start counting from the first element. Na, I've got 1, Na, I've got 1. 2 Cls, only 1. Remember, if there's nothing here, we know there's a little 1 there. So I'm going to put a big 2 there, and then I realize I got to go back and fix that. So those are a couple of simple synthesis reactions. Just taking 2 elements, bringing them together, right? Easy enough. The next 2 types are the ones that are a little bit trickier, but not too bad, all right? So our next one is a metal oxide plus water, and that's going to give me a base. All right, so leave that up here. This is a type of synthesis reaction. So for example, CaO, calcium oxide. All an oxide is it's a compound that has something and oxygen. Something, our metal, calcium, and oxygen together. We'll add water to that, and that's going to give us calcium hydroxide. Right? Calcium's a 2, it comes down here. Hydroxide would be a 1, it goes here, we don't show 1s. So there's our skeleton equation. I go through, let's balance this thing, make sure it's okay. 1Ca, 1Ca, 1O, 2 O's going in, 2 O's going in, whatever is in the brackets is doubled, so 2 O's going in, 2 H's and 2 H's going in. So this is one of those ones we talked about. We did the formulas properly and it's already balanced, so I don't have to touch anything there. The next example of a metal oxide, lithium oxide plus water yields lithium hydroxide. A lot of our bases, not every one of them, but a lot of the bases we'll be using have hydroxide in them. You can see both of these have that hydroxide ending to them, right? It's very commonly found in a lot of bases, that OH ending. So here's our metal oxide. Again, an oxide is just anything that has oxygen combined with something else, in this case lithium. So metal oxide, water, base. So let's start double checking our balancing here. 2 Li's, only 1, we'll put a 2 there. So 2 Li, 2 Li. 1 plus 2 O's, 2 O's. Remember this 2 accounts for all of this now. So 2 O's, 2 H's, and 2 H's. So all we need to do is add this 2 right here. So again, very common reaction in chemistry. A metal oxide and water combine to give us a base. A metal oxide and water combine to give us a base. All right, these are on your notes. I know you can already see them. I just like to go over them with you because normally we would in class. All right, the last type of reaction for synthesis. Now there are other reactions out there, but these are the ones that we're going to be doing in class. Takes a non-metal oxide and water and makes an acid. All right, so a non-metal oxide is, well, it's an oxide, which means it's a compound that has some element and oxygen. An example of one, sulfur trioxide. It's a covalent compound because it's 2 nonmetals. Oxygen's a nonmetal, and obviously sulfur is the other nonmetal. So sulfur trioxide, using my prefixes there in the name, water. And what this will combine to give us is sulfuric acid, right? If you remember, this is sulfate, right? This is a ternary acid, has one of those polyatomics. So there's sulfate, and 8 becomes ick. I ate something icky. So this is sulfuric acid. So this is an example of a synthesis reaction. I've only got one product at the end here. These two combined give us this. So let's double check our balancing. S, I've got 1 S. 3 O's plus 1 O gives me 4 O's. Everything good so far. 2 H's, 2 H's. That's perfect. Remember, when we're balancing, we treat this like it's an equal sign. The stuff before the arrow has to equal the stuff after the arrow when we're writing it down. The next one. All right, here's a weird looking compound right here. Oh, and I messed it up. Makes it even more weird. So it's Cl2O7. Do you remember how to name these? Dichlorine heptaoxide. Right? Dichlorine heptaoxide. Hepta is the prefix for 7. And water, and it makes, how are we going to name this? That is, let's see if I remember. Chlorate was ClO3. This is ClO4, which is one more. So this is going to be perchlorate, right? Perchlorate. So this acid's going to be perchlor, and 8's become icky, so perchloric acid. So we made perchloric acid by combining these two things here. So let's go through, and we have to double check perchlorate is a 1, hydrogen is a 1, so we're good that way with the formula, right? So let's go through, check our balancing. 2 chlorines, only 1 chlorine here, so I'm going to put a big 2 right there. Let's see. So 2 chlorines, 2 chlorines. Oxygen, 7 plus 1 is 8, and 2 times 4 is 8. Good there. And then 2, and then 2, so we're good. So that's our reaction there. We just had to add the 2 there. No problems. So these are your synthesis reactions. Kind of worked out nicely for you. Now, if I erase something that you wanted up there for a moment longer, remember, it's a YouTube video. You can just pause it and take a look at it and then resume the lecture whenever you want. That's the beauty of this. So those are synthesis reactions. Nice and easy. Let's bring our thing back in here. All right. Our next type of reaction is a decomposition reaction. So a decomp in a movie, right? If you're watching a cop movie or a murder mystery or that, a decomp is a body that's, you know, someone's being killed and they put them out in the woods or wherever, and they've started to break down. They're decomposing, right? So decomposition, or in French, decomposition, what it does is it breaks things down. In fact, it's the exact opposite of a synthesis. A synthesis takes little components and builds. This thing takes something large and breaks it up into smaller pieces. So let's take a look here. A decomposition reaction occurs when a complex substance, a larger substance, breaks down into 2 or more simpler substances, or its components, right? A lot of the time we see heat being used to get these reactions to get going and go quicker. So when we do employ heat, it's called a thermal decomposition, right? And we see this, they found that woolly mammoth in Siberia, the most northern part of Russia. It's up in the Arctic and that. And it was perfectly preserved almost. They found it locked in the ice. And the reason the woolly mammoth didn't decompose like a body normally would is because it was so cold. If that same woolly mammoth was down in Mexico or someplace where it was really, really warm, it would break down much quicker and there wouldn't be very much left to it at all, right? So heat helps break things down. Decomposition and synthesis, like we just mentioned, are total opposites, right? Synthesis makes, decomps break, right? So here's our general equation, right? AB gets broken apart into A and B, right? And if we're using heat, say we're doing a lab, which, God, I don't know if we'll ever get into the lab again in this year because of the pandemic, but if we're using heat, like a Bunsen burner or something like that, we would put the little delta triangle there, or if we knew the exact amount of heat, let's say we were boiling it at 100 degrees Celsius, we could do that, right? One of the last things we did before class got called and we were all forced into isolation. So what's our key here going to be? Well, our key here is going to be our hint. There's only one thing going in. If you remember the synthesis, only one thing came out. Here, only one thing goes in. So look at all of our examples over here. Only one substance, ammonium nitrate. That's it. There's no plus anything else. It's just one compound. And it got broken down into dinitrogen monoxide and water. Calcium hydroxide, a base, got broken down into calcium oxide and water. And then hydrogen peroxide got broken down into water and oxygen gas. So in all of these cases, a larger compound got broken down into a couple of components. At least 2, sometimes 3, 4, 5, depending on the size of the initial substance, the reactant that you start with. All right, so let's go into some examples. Again, this next couple of slides, these next 2, this one and the one that follows, I added just recently and reloaded onto your site. So if you're getting these off of D2L now, this is here. If you got it earlier or prior to this week, then this slide won't be here. I'll do them out on here, but go back and you can get this off your D2L page. So our simple decompositions, it's the ones where we just have two elements and we're splitting apart the elements. And I'll go over a couple of these with you. Then we're going to talk about chlorates, and I'll go over those with you. You can see chlorates are here. There's a chlorate, there's a chlorate, and they break down into a couple of known things. And then our next one, carbonates, which are CO3s. So we take various carbonates that are combined with metals and we break those down. I am going to go over these with you. So sodium carbonate breaks down, zinc carbonate breaks down, and then hydroxides. Hydroxides have the OH, right? These are both on your polyatomic table, carbonates and hydroxides. So we take a metal hydroxide and break it down, right? We're breaking down bases. We just learned how to build bases, so it's the exact opposite actually to that. So let's go over a couple of these each. Now the single displacements, that's going to be another lecture, so I'm going to move this and we'll get that out of the way. All right, so our decomposition reactions. Shorthand for reactions, I use RX. So the first one, simple decomps, right? A simple decomposition reaction. For example, taking lead to oxide and breaking it down. Well, there's only two things I can get from that. There's only two elements there, so Pb is one of them and O is the other one. And we know any metal by itself is by itself. O is a diatomic gas. It's oxygen gas. So we look at this one, Pb, Pb, good. 1 O, 2 O's, not so good. So we will put a 2 here, and then it looks like we'll have to put a 2 there. Done. The next one is nickel 3 oxide. Nickel's a shifty metal. It has different valencies, but we didn't go over it in class. It's not one of our main four. But we have nickel 3 oxide here. And of course, again, it's simple. It can only break down into nickel and oxygen. That's the only things that are there. Nickel, oxygen gas. Any metal by itself is by itself. Oxygen is a diatomic gas. So we look at this and we go, okay, at first we're thinking nickel, I've got 2. This should be a 2. Oxygen 3 and 2. There's that 3 and 2 we commonly see in chemistry. I've got to make 3s and 2s into 6s. That's the lowest common multiple. So 3 times 2 is 6, and 2 times 3 is 6. 6 and 6 when I multiply those. And then we got to go back and start again because I can see I've altered my nickel, which I thought was already fixed. I've got 2 times 2, which is 4. So this 2 has to become a 4. All right. And then we've got another example that we have water can break down into hydrogen gas and oxygen gas. And when I balance that out, it ends up with a 2 here and a 2 here. All right. So those are simple decompositions, pretty easy stuff. We'll get into the other ones here. Now chlorates. Chlorate decomposition. So this is the second, I'll put a little 2 here. This is the second, that didn't come up very well, now did it? Take your time here, dude. This is the second type of decomposition. So chlorate decomposition. What we're going to see here every time is a metal chlorate. And it's going to break down and give us a metal chloride and oxygen gas. running out of space here. Anyway, metal chloride, I'll do a couple of these really quickly for you. So, a metal like potassium. And chlorate, we remember, is Cl, it's polyatomic, it has that 8 ending, ClO3, right? Chlorate has a 1 minus charge, potassium has a 1 plus charge, right? So they are both 1s, so my formula is good. These two ones, they reduce. Our formula is fine. All right, chlorate, if we remember, is ClO3. It's got a 1 minus charge. In your note, I put this in right here, I believe, in your note. So that's going to break down into a metal chloride. Well, my only metal is potassium, and chloride just means Cl. All right, I'd means I'd rather be alone. Chlorine is by itself. It got rid of the O's that were with it. The O's go back here in the form of oxygen gas, which we know is diatomic. So now we take a look at it. We have to balance this off. 1 potassium, good. Chlorine, good. 3 oxygens, 2 oxygens, not so good, but that's an easy fix. We're going to turn them both into, when we have a 2 and a 3, into 6. So 2 times 3 is 6, and 3 times 2 is 6. And now we've got 2 Ks and 2 Cls, so I'm going to put a 2 in front of this. Our next example, magnesium chlorate, and it's going to break down to a metal chloride, so my metal is magnesium. Chlorine, now this is a 2 and that's a 1, so that 2 is going to come down here, so it's magnesium chloride is MgCl2, and oxygen gas is still O2. So if we look here, magnesium, 2 chlorines, 6, 2 times 3 is 6 oxygens, and only 2, so that's an easy fix. I just throw a 3 there and we're all balanced off. So again, I can see with a chlorate decomposition, here's my metal chloride, or chlorate, sorry, metal chlorate, another metal chlorate. They'll break down, give us a metal chloride, and oxygen gas. Pretty straightforward, pretty easy. Go into our third type of the 4. So these aren't too bad. Our third type, carbonate decomposition. Now carbonate, if we remember, is CO3. It's got a 2 minus charge. All right? So what we see here is a metal carbonate, and it's going to break down and give us a metal oxide and carbon dioxide. Hopefully my penmanship isn't too terrible. So that's the pattern we're looking for. A metal combined with carbonate. Remember, metals have positive charges. Carbonate is a negative charge, so they'll go together. A metal oxide and carbon dioxide, CO2, is going to be in all of these. So we'll do a couple examples of these. We'll do zinc carbonate. Zinc is a 2, carbonate is a 2 in terms of their charge, so they're good, but this is a good formula. Metal oxide, my metal is zinc. Oxide means it's with oxygen, so zinc oxide, and carbon dioxide, CO2. And let's take a look. Zinc 1, 1 carbon, 3 oxygens, 1 plus 2 is 3 oxygens. So this one worked out perfectly by itself. We'll do another one here. Sodium carbonate is Na2CO3. It breaks down into, my metal is sodium, and oxide means it's with oxygen, so Na2O, and carbon dioxide is always going to be CO2. Check if it's balanced. 2 sodiums, 2 sodiums, 1 carbon, 1 carbon, 3 O's, 1 plus 2 is 3 O's. So again, this one's already balanced. All right. Now I think also on your slide you had copper 2 carbonate breaking down, and it kind of went along the same pattern as this. All right. So carbonates, a metal with carbonate, metal, carbonate, metal, carbonate, breaks down to give me a metal oxide, metal oxide, metal oxide, and carbon dioxide. All right, easy enough. All right. You'll be looking for these patterns when you do the sheet that is now posted to your D2L site. The last one, finally the last one. So this is the 4th type of decomposition reaction, and it's the breakdown of hydroxides. Now we said just previously hydroxides are very commonly found in bases, so a lot of times we're going to be breaking down bases when we do this. So we take a metal hydroxide, it breaks down, it decomposes. We're going to get a metal oxide, very similar to what we got in the last one we just did. Instead of carbon dioxide this time we're getting water. Now the easy part about this is if we were to reverse these, take a metal oxide and water, we'd get a base. All right, the reverse of this was like a synthesis reaction we just covered a little while ago, right? So not too bad. So we'll take a couple of examples here. I'll use a different color for contrast. NaOH, metal, Na, hydroxide this. Hydroxide is OH, and it's got a 1- charge for when you're making formulas. I believe I put that in the notes right here. So NaOH breaks down my metal oxide. The only metal is Na, and when it is with oxygen, it's Na2O. And there's my water. To balance this out, 1 sodium, 2 sodiums. So 2 sodiums, 2 sodiums, 2 O's, 1 plus another one is 2 O's, so that's good. 2 H's, 2 H's. So all I had to do is add that little 2 there. Everything is all good. The next one, CaOH2, calcium hydroxide, another base, breaks down. My metal is calcium. It's an oxide, so it's with oxygen. This is a 2, that's a 2, so that formula is fine. And there's my water that I get at the end there. To balance this, Ca goes in, Ca comes out. Good. 2 O's, because whatever's in the brackets gets doubled. 2 O's, 1 plus 1 is 2 O's. 2 H's and 2 H's. So there's an example there where if we do the formulas right, it's already balanced. And I'll squeeze in one more here just because I got a little bit of room. Aluminum hydroxide will break down into my metal, which is aluminum, and oxide. When I put those two together, that's a 3, it goes here, that's a 2, it goes there. And water. And to balance this one off, 1 aluminum goes in, 2 aluminums come out, so I'll put a 2 there. 2 aluminums, 2 aluminums. This is where it gets a little bit tricky, but we already counted at them, so we know what to do here. Oxygen, I've got 1 times 3, which is 3, times 2, which is 6. Now I've got 3 here and 1 here. Maybe I'm not sure what to do about the oxygens. So what I'm going to do is I'm going to go on to the next one and see if I can fix it by kind of doing everything else and seeing if it makes oxygens happy. Because I'm not sure, should I be doubling this? Should I put a number here? I don't know. Let's try the hydrogens. We'll come back to those oxygens. So 2 aluminums, 2 aluminums. Let's try the hydrogens. There's 1 inside the bracket. Times 3 is 3. Times 2, which is 6. I've only got hydrogen here, so 2 times 3 is 6. So let's start again. 2 aluminums, 2 aluminums. 2 times 3, which is 6 oxygens. 3 oxygens here, and now 3 oxygens here. It balances it out for me. So sometimes if I don't know what to do with one element, I'll try to balance out all the others, and you'll see that it will get fixed. Anyway, that's the end of it, right? So we've done synthesis, 3 different types of synthesis reactions that are very common, and we've done 4 different types of decompositions that are very common in chemistry. There is a worksheet on your D2L site, synthesis and decomp reaction worksheet. So download that or write that into your notes and give that a try. And I know I'll be on later and we'll go over the answers to it. Anyway, thank you for watching, and see you soon. All right, bye-bye.